things with the force. And this Coulomb force, if I have several different source charges at different locations, and how we end up having something that we can sort of pull stuff out of when we add up. The force is on the same test charge, so that can pull out, and our 1 over 4 pi epsilon naught, also known as K, can pull out front. And then we have individual charges that have that.
I have one question. Okay, you see how both of them have Q's, but you took one out, just cancel out both of the Q's, then on the other side, the big ones?
No, so the big Q comes out of each term, and so that factored out front.
Okay.
The little Q's are individual ones, and so they're inside the summation. And what we say is that if we just take this big Q out, we're left with this equation instead of the sum of all of this without the big Q, and that's how we define the electric field. Because the electric field is defined as the force divided by that test charge. Now, in general physics, we had used a Q naught. Here we're using that capital Q. And so when I divide the capital Q, it divides out of every term. And so we're left with this function down here. Okay? Now I'm going to take that and I'm going to blow that up a little bit more. So this is the electric field So a collection of point source charges, Q1, Q2, Q3, Q4, etc., are labeled in here, and we have their charges and their positions. And so these separations are for a particular field point.
And that's what it means on the side with that?
Yeah. And so this is going to give us the electric field at one field point and if we're lucky, it's actually able to be written as a function of x, y, z. Otherwise, you would want to use a computational approach to finding the field. And again, a field means that at every point in space, we have a strength of the electric field and a direction.
Field. What's in the green man right there?
At every point, you have a strength, the magnitude of the electric field, and electric field. Now, ultimately here in the next lectures, we're going to look at both the computational approach, because if they're just random source charges in different places, you'll have to use a computational approach. Or we'll look at some nice cases where we can end up working this out symbolically. Okay? So this involves a lot of calculations, because for each field point, you'd have to calculate the separation and then calculate the summation over all the source charges using each charge and its separation to find the electric field at one field point, and then repeat that calculation at different field points. Now, that's the electric field for point source charges.